Hello guys, welcome back to a new session. In this session we'll be talking about the second section of chapter 10, which is about the other organic compounds. Guys, more organic compounds. First we'll be talking about the aldehydes and ketone, which they are responsible for the odors. Let us talk about the functional group of the aldehyde and ketone. Why we talk about both together? Because they have similar functional groups to each other. Aldehydes and ketone contains both the carbonyl group. Carbonyl group is C double bond with O. So this is a carbonyl group that both aldehydes and ketones, they contain this group. The difference between aldehydes and ketone, which they both contain carbonyl group, is the location of the carbonyl group. Let us talk how the location is different from the aldehyde to the ketones, guys. How the location is different from the aldehyde to the ketones. Aldehydes are organic compounds in which the carbonyl group C double bond with O is attached to a carbon atom at the end of the chain. At the end of the chain. General formula is what? As you can see, carbon by double bond with O, which is a carbonyl group, and then this end is closed by H. That end is the hydrocarbon, R. So one end is closed, the other end is open. But the ketones are organic compounds in which the carbonyl group is attached to a carbon atom within the chain, not at the end. As you can see, carbon bonded with oxygen or carbonyl group in both ends is open for the hydrocarbons, for the chain of the hydrocarbons. So whenever it's at the end of the chain, the carbonyl group, it becomes aldehyde. At the middle becomes ketone. Let us name the aldehydes and then ketone as well. Guys, for the naming systematic all based on the alkanes which we name. Longest chain that contain the carbonyl group C double bond with oxygen. And then add the suffix of Al because it's aldehyde to the prefix correspond to the number of the carbon. For example, ethanol, propanol, butanol, and so on, guys. Please have a look. Carbon attached to oxygen and this end is closed. So if it's closed with the hydrogen, that represents the aldehyde. And then we have got another CH3. So how many carbons do we have? It's ethane, but it becomes ethanol for the aldehyde. So it's what? It's ethanol. Let us name more examples. Let us have more example, and then we will name the ketones as well. Guys, in this case, have a look. The carbon attached to hydrogen to oxygen by double bond carbonyl, and from this end is closed, that end there is nothing. This is one carbon, methane. It becomes what? Methanol, or we call the formaldehyde. Later we will be talking in the properties methanol. The other one, C double bond with oxygen, which is carbonyl group, and 3 carbons, it becomes propanol. If we have branches, the same, we name the branch and then the parent. 1, 2, 3, 4. The number starts from the carbonyl group here. On the second, we have got a methyl. So it's what? 2-methyl and 4-butanol. 2-methyl, 4 refers to the butanol. That's the example, some of the example and the naming of the aldehyde. Let us talk about the ketone, how to name the ketone. It takes a suffix of ONE, unlike the aldehydes, guys. Locate the longest continuous chain that contains the carbonyl group, but here the carbonyl group is not in the end, at the end of the chain. It's in the middle or in between the carbons. Suffix of ONE instead of AL corresponding to the number of the carbon chain. For example, it's propane, it becomes propanone, butanone, pentanone, hexanone, ONE. Number the carbon atom in the chain so that the carbon atoms in the carbonyl group has the lowest possible number. The carbon atom in the carbonyl group has the lowest possible number. Insert the position number and punctuate the name. Let us name these structures and solve some of the examples, guys. Solve some of the examples. How do we know this is ketone? Because it's in between two carbons. It's not at the end. It's not carbonyl group C double bond with O with the methyl and the other methyl. I mean, it's three hydrocarbons. 1, 2, 3, 1, 2, 3 from each end. The carbon gets the same. So you have to position the number of the carbonyl group here, which is on the second, and then name the parent. So 2-propanone, the first location of the carbonyl group, and then propan is the name of the parent chain, and ONE is a suffix of ketone. More examples. Here from this end, the carbonyl group is second, from that end is third, so you have to name according to the carbonyl group to get the least possible number. From left to right is the correct selection and correct position of positioning the number 1, 2, 3, 4. It's 2-butanone, 2-butanone. Here, from this side 3, that side 3, it is depends on you. I mean, it has no problem, doesn't matter from which side you position the numbers. It's 3-pentanone, 3-pentanone. That's how we name the ketones and aldehydes. Ketones and aldehyde, they have properties. Let us talk about their property. Simplest aldehyde is methanol. Methanol is the simplest aldehyde, which is C double bond with the H and H. This is methanol, guys, which we said it's the common name is formaldehyde, has a known as the formaldehyde. Formaldehyde is biologically in laboratory used as a preservative for the dead animals or the dead body. It's used to preserve or protect the dead body from spoiling. Most important commercial use in production of plastic. Also, it's used for the production of plastics, this aldehyde, and then we'll be talking about the ketone. Bakelite was made by combining phenol and formaldehyde. See the phenol, this is phenol, guys, phenol, which is the common name of this structure. Phenol is an alcohol combined with the formaldehyde to form the bakelite. The bakelite is used in the production of the plastics. The ketone, guys, simplest ketone is 2-propanone. 2-propanone, whose common name is acetone. Acetone is commonly used for the removing the nail polish. Acetone is found in some nail polish removers because it dissolves organic substance in nail polish. Aldehydes and ketones are often responsible for odors and flavors. As I told you, they are responsible at the beginning for the odors and flavors as well. Cinnamon aldehyde contributes to the odors and flavors of cinnamon. As you can see, guys, here the picture, the cinnamon aldehyde, irony, and then the raspberry ketone, and vanillin, benzaldehyde. These are all the structures. They are all aldehydes and ketone, and they have different tastes, flavors, and smells. and odorous as well. The aldehydes and ketones, we talked about them. They have the carbonyl groups, the aldehyde at the end of the chain, the ketone between the two carbons. That's the only difference. The carboxylic group. Let us talk about the carboxylic group, which still also they contain carbonyl group, functional groups. Are organic compounds that contain the carboxyl functional group, which are the C double bond with the O and then OH. The carboxyl group always comes at the end of the carbon atom chain. So must come at the end of the chain of the carbon. General formula is C bonded with double O and then OH. This R is the chain which can be as long as possible, depends on the number of the hydrocarbons. So the difference, we talked about C double O H and then here the R, C double O R R, C double O O H. They are almost resemble to each other. This contains a carbonyl group, but it's closed in one end. It contains a carbonyl group, but open in both. This contains a carbonyl group and closed by the, we call as the carboxyl group by the OH. Guys, carboxylic acid nomenclature. Let us talk about the naming systematic. We have first locate the longest continuous chain that contain the carboxyl group. Contain what? The carboxyl group. If there is only one carboxyl group, add a suffix of oic acid. Oic acid. So for example, methanoic acid, ethanoic acid, propanoic acid. Corresponding to the number of the carbon atom in the chain depends on the parent, how long is the parent. If there is more than one carboxyl group corresponding to the name, add the suffix of modified to indicate the number of the carboxyl group according to this. Dioic, trioic or tetraioic if there will be 4 carboxyl group in the state, but we have usually up to 3 carboxyl group in the structure, guys. Let us name it. Let us solve some examples, guys. Here, how do we know it's carboxylic acid? C double bond with H and O double bond with O and OH. How many carbons do we have? 1 carbon, so it's methanoic acid. Methanoic acid. The other one, it's 2 carbons. It's what? Ethanoic acid. Ethanoic acid, which is acetic acid, CH3COOH. And if we have 4, it's butanoic acid. Butanoic acid. More examples, if we have more example, and then the branches. So as usual, we name the branch and then the parent. As usual, we name the branch and then the parent. But the numbering starts from the carbon, which is a carboxyl group. So you have to start from here. 1, 2, 3, 4. So on the third, we have got a methyl. 3 methyl. The chain is what? 4. Butanoic acid. 3 methyl butanoic acid. For this structure, we have got 2 carboxyl group, COOH and then COOH. 2 carboxyl group is what? Dioic or 3 trioic. For 2 carbons, we have ethane and then dioic acid for the 2 carboxyl group. Here we have got 1, 2, 3, 4. The parent is 4 carbon. We have got 2 carboxyl group. So we have to use the butane dioic, pentane dioic, hexane dioic acid. That's how we name the carboxylic groups. Let us talk about the properties, guys. Carboxylic acids, like inorganic acids, react to lose a hydrogen ion and become a negatively charged ion, guys. CH3COOH, which is the carboxylic acid ethanoic, they have tendency to donate proton or lose proton in order, according to Bosch theory, to become acids. As you can see here, guys, we have got methanoic reacts with the H2O, reduces a proton from the OH. This OH donates a proton to the medium. Carboxylic acids are much weaker than many inorganic acids such as hydrochloric and nitric acids. Comparing the carboxylic acid with the inorganic acids, they are much weaker than them. Acetic acid, the weaker acid in vinegar, is a carboxylic acid. The acetic acid is ethanoic according to the IUPAC system, and the acetic acid is the common name of the ethanoic. A number of carboxylic acids occur naturally in plants and animals. There are several carboxylic acids contained in the plants and animals, like for example citrus fruits contain citric acids, which are the carboxylic acids. More properties of the carboxylic acid, guys. Carboxylic acid are also used as food additives. Sometimes we use as additive for the foods in order to be, for the flavoring, as a flavoring agent. Ethanoic, which is acetic acid, used in vinegar, and citric acids are used in foods to give them a tart or acidic flavor. As we said, we use the carboxylic acid to provide the flavors to the acidic flavor to the foods. Benzoic, guys, propanoic and sorbic acids are used as preservatives. They use it as preservatives to preserve the foods or preserve the compounds, the organic compounds. All three acids kill microorganisms that cause foods to spoil. Usually, these three compounds can be used to preserve the foods, as we said, in order to prevent them from spoiling. Most widely used carboxylic acids are methanoic and ethanoic. We use the methanoic and ethanoic most widely commercially because they can be made inexpensively. In terms of prices, they are inexpensive. That's why they do have most applications or most commonly used carboxylic acids. They are starting material for many chemical processes. They are the raw materials for many processes, guys. Ethanoic acid is used in the production of polyvinyl acetate PVA, and PVA is used in latex paint adhesives and textile coating. It's used PVA for as the paints or for the production of the textile, the clothes coating. Let us talk about the esters. We talked about the carboxylic acid, aldehydes and ketone. Let us talk about the esters, their structure, the general form, the naming, and then the properties. Esters, guys, are organic compounds that have carboxylic acid groups in which the hydrogen of the hydroxyl group has been replaced by the alkyl group. The esters, as the carboxylic acid, they have carboxylic groups. But the only difference is that in the carboxylic acid, we have got COOH with the OH and R, as you can see. But here, the carbon double bond with the O, and then with the O, but instead of H, we have branches, and then at that end also, we have a parent. So, the one that attached to the R in the O end becomes a branch, and the one in the other end becomes a parent name. That will be for naming is very important. Esters are considered as a derivative of carboxylic acids. They are the derivative derived from the carboxylic acid because of their structure similarity to the carboxylic acids. They contain carboxyl groups, guys. Let us talk about the naming. The naming of the ester. We have to know how to name the ester. Name the carboxylic acid from which ester was formed. Change oic ending to the OAT. So the ester, in ester, the name of the parent, instead of taking oic, it becomes oit. Oit. Identify and add name of the alkyl group to the front name. As the others, we have to name the alkyl group and then leave appropriate space in the name between the alkyl group with the parent name. Guys, how to know this is ester? Carbon attached by double bond to oxygen, and then by one bond to oxygen, this becomes the branch. So don't forget to mix the branch with the parent. This is the parent, and here we have got the branches. First of all, you have to name the branch and then the parent. The branch is what? Is ethyl. Ethyl. And a space. The two is ethanoic according to the carboxylic acid, but it becomes oit, ethanoid. Ethanoid. This refers to what? To the ester naming. In terms of naming, ester is easy to name, but do not confuse the parent with the alkyl group. This is the alkyl group, and that's the parent. Okay, guys, the alkyl group is ethyl, and the parent is butanoid. Ethyl butanoid, methyl ethanoid, which is 2. Or we can say here the alkyl group is propyl ethanoid. Propyl methanoid, guys. Propyl methanoid. The properties and uses of esters. We'll be talking about the usage and applications, the properties of ester as well. Esters are commonly in plants and are responsible for some distinctive flavors and odors. The esters, they are somehow resemble resemble to the aldehydes and ketone, used for the odors and flavoring. Isoamyl acetate, which is found in bananas and is also used as artificial flavoring for the bananas, is ester, guys. Chemists have learned how to synthesize natural compounds for uses as food additives. They use the esters for the food additives or the flavoring agents for the foods, and the only example in our book is what? Is isoamyl acetate, which is the flavoring of the banana. Let us talk about the amines. Amines are another group of organic compounds which they are responsible for the odors, but the worst odor, the bad odor of spoiled compounds. The spoiled compounds. Guys, the amines are organic compounds that can be considered as derivative of ammonia. We derive the amides or amines from the ammonia. Amines are not named according to IUPAC. We name according to other systematic naming. We do not name them according to the IUPAC naming. The general formula is N attached to 3 R's, and the 3 R can be the chain of the hydrocarbons, or there can be hydrogen attached to it instead. Amine nomenclature, the end of the name will take the amine, the parent will take the amine as well, and then add the name of the alkyl group attached to nitrogen atom in alphabetical order. For example, ethyl, methyl, propyl amine, or butyl, ethyl, methyl amine. That's the name in alphabetical order. If there is more than one alkyl group attached, add a di, tri in front of the alkyl group. This is, we learned this. Here, combine the name in front of the amine, and then use the amine in order to, as the parent, to know it is amine. Okay. The first one, guys, it's composed of or connected to CS3. CS3 is methyl, so this is methyl amine. Primary amine is what? Methyl amine. Secondary amine, which is ethyl methyl amine. Ethyl methyl amine, it becomes a secondary amine. Our tertiary amine, it's what? Trimethyl amine. So, guys, methyl amine is primary amine, ethyl methyl amine is secondary amine, trimethyl amine is what? Tertiary amine. A primary amine, secondary and tertiary are what? Let us talk about them. A primary amine is one hydrogen atom of an ammonia molecule has been replaced by alkyl group. As you can see, we have got 2 hydrogen here. Only one of the hydrogen replaced by the alkyl groups. But secondary amine, 2 hydrogens replaced by the alkyl group. Tertiary amine, all hydrogens, the 3 hydrogens replaced by the alkyl groups. Properties and uses of the amine, guys. How to, what are the properties of amine, the usage and the applications? Chemical properties of amine depend largely on the electronic structure of nitrogen, which has unshared pair of electrons, guys. Nitrogen, as you can see, it has got this structure, okay? This is ammonia, NH3. The nitrogen has got a pair of electrons which is unshared, and most of the property of amine depends on this electronic structure of unshared pair of electrons. Region of negative charge makes amine weak base in the aqueous solution. So the amines, the derivative of ammonia, you know, is a weak base, and they work as the weak bases. Unshared pair of electron on the amine molecule attracts a positive charged hydrogen atom in water. So it has tendency to attract a proton in order to be a base. As you can see here, we have got N attached to 3 R's plus H2O. It becomes what? It obtains a proton from H2O to become a what? To become a base. But usually they are weak bases. Ionization of weak base is represented by that reaction which is from the amine. We have got some other properties of amines. So we said the amines are dealing as the weak bases in the aqueous solution. Here, guys, batrachotoxin and batrachotoxin A, these are 2 amines which are responsible for what? As natural toxic amines, those produced by the poisonous frogs. Batrachotoxin and batrachotoxin A, they are both poisonous chemicals, amines that produced by the poisonous dart frogs. It's produced by the frog, these 2 amines. Amines are common in nature. we have got amines in nature. They are often formed during the breakdown of proteins in animal cell. When we break down the proteins, we will get the amines. One of the amine is what? Alkaloids. The alkaloid are naturally occurring amine products of plant that have physiological effects on amines such as caffeine, nicotine, morphine, and cunnin found in poisonous hemlock. Guys, the alkaloids, when the animal they take the alkaloids, they have the properties of drugs, the alkaloids, which are the amine, and it affects on the psychological efforts of the animals which they take this, like the poisonous hemlock, which is a leaf or a tree. When the animals they take, they feel relaxed, and they have the same effects as the drugs of cunnin, morphine, nicotine, and the caffeine as well. Amine are recognized by their four odors, such as in decaying body, dead fish, and faces. As I told you, amine are responsible for the four odors. The worst odor of the dead fish, decaying body, or the faces from the emissions of the animal or the human being as well. The bad odor is the amine which is responsible. Guys, those compounds that we studied they are responsible for the odor and flavor. First, aldehyde, then ketone, carboxylic acid, alcohol, amine, and ester. They are all compounds which they are responsible and related to the odor and flavoring of the compounds. Here we have got a table. The table is a summary for those groups of organic compounds that we studied. As you can see, the alcohol, they have the general formula of ROH. Any compound contains OH are the alcohol, and the name takes the OL. And here we have got an example. The name of the example, which is 1,3-propane triol, which is glycerol. Alkyl halides, the RX is the general formula, and takes the fluorochlorobromoiodo as for those. And here we have got 1,2-dichloropropane is the name which is written here. Ether, which is the O connected to two chains of hydrocarbon. The chains are what are both the alkyl groups. You can say ethyl, methyl, ether. This is ethyl, methyl, ether. And then aldehydes and ketone would be, they are two compounds that they contain carbonyl groups. They are responsible for the odors and flavors as well. Aldehyde contain carbonyl group at the end of the chain, which written as this, and then R, it becomes the parent to it, which is this is ethanol, takes the suffix of Al to the naming of the parent. Ketone, it's in between two R's, which are the chains. It becomes what? The 1, 2, 3. Here we have to number the chain. Second, it takes the ONE, propanone, 2 propanone. And then carboxyl acid, they have the carboxyl groups in their structure. The carboxyl group is C connected to oxygen with the OH, and then the general formula is closed in one end and opens to the other end. This is takes the naming ends or the suffix of oic. As you can see here, we have got 2 carbons. So the 2 carbon is what? Is ethanoic acid, acetic acid in vinegar. Let us talk about or revise the ester and amine as well, like the others. Ester and amine. Ester has the same carboxyl group, but instead of the O attached to H, attached to the alkyl group. This becomes an alkyl group. That's the parent, the other R, and takes a suffix of OAT E to the name. Here we have got a methyl ethanoate as an example. Amine, the structure is N attached to three R's. If we have only one alkyl group, we call as a primary, two alkyl group ternary, and three alkyl group secondary, and three alkyl group ternary or tertiary amines. Here we have got two groups, which is secondary, and dimethylamine takes the name of the parent